special presentation from Channel 6 News, Storm Warning 2.
The whole house came apart.
Very scary.
When I seen it, I don't know how she survived. God was definitely watching over her.
The tornado lifted here, jumped that house there, and went down in the gully.
Through the evening and early nighttime hours on July 21, 2003, countless people from Greene County, New York to Bennington County, Vermont were subjected to a moment of terror from the sky. This is an indication that we have a potential tornado.
Sounded like a grenade went off.
It's devastating. It's totally devastating.
This could also affect portions of extreme southern Rensselaer County.
The building is gone. The mobile home is gone.
Nassau, under the gun right now with what looks to be some of the most intense weather.
The news came over saying that there was a tornado warning.
All of a sudden the wind started to kick up, and boy, it really took off from there. It just tore everything right up. Houses and windows and roofs and everything started flying by.
10-15 seconds. That's all it took for everything just to go crashing. Back windows shattered. My sister screaming. Dogs crying. It was just 10-15 seconds.
This again is the strongest moving into Columbia County, which is why the National Weather Service has prompted the tornado warning for Columbia County.
I heard the wind and a big loud boom and a bright blue flash, and the tree came down, and thank God nobody was walking underneath.
The tornadoes on July 21, 2003 are a vivid reminder that we're vulnerable to destructive storms. I'm meteorologist Steve LaPointe. Thanks for joining Storm Warning 2. We'll be looking at July 21st again with some insight into why the tornadoes happened. We'll highlight some local hotspots where severe storms seem to occur more often, and we'll also look at lightning and hail, as well as review all the safety information you should know to protect yourself and your property when violent spring and summer weather strikes.
I'm meteorologist Tom Maley. Severe thunderstorm and tornado watches are issued for large areas before thunderstorms form. This is your first alert to the potential of severe weather later in the day. A warning is issued when Doppler radar or ground spotters indicate severe weather is occurring. When a warning's issued, waste no time, take cover. In the Northeast, a severe thunderstorm produces winds of at least 58 miles per hour and or hail at least 3/4 of an inch in diameter. These are the threshold levels where wind and hail typically produce damage. The amount of lightning plays no role in defining a severe thunderstorm.
A thunderstorm, once it forms, can become severe very quickly if conditions are right. And in our area, there's evidence to suggest that severe thunderstorms are favored to develop in certain local hot zones. Here's meteorologist Mike Augustyniak.
Flattened trees and demolished buildings were the result of two tornadoes that formed early in the evening of May 29, 1995 in Columbia and Berkshire counties.
It was so black and the air was so thick you couldn't read, you couldn't see.
I thought, this is the end of the world, this is it, because it was, I'd never been in a tornado.
You can still make out the path of the tornado that took 3 lives here over this hillside of twisted trees in Great Barrington almost a decade later, a true testament to the strength of the storm. This wasn't the first storm that this area saw, and it won't be the last. Because the Berkshires are part of a local severe weather hot zone that also includes New York's Hudson Valley. On average, there's a tornado in this region every other year, as some notable storms, including the violent West Stockbridge tornado on August 28, 1973, that killed 4. And more recently, the July 3, 1997 outbreak of up to 10 tornadoes that began in southern Columbia and Berkshire counties, hitting some of the same communities that were torn apart in 1995. And this isn't the only local hot zone. Severe thunderstorms and tornadoes also tend to occur more frequently in a path from near Amsterdam to the Mechanicville area and into northern Rensselaer County.
Was the church that was damaged in the 1916 tornado.
Dr. Paul Lotman is Mechanicville's town historian.
I ran across references to tornadoes in this area or cyclones either here or nearby in 1867, 1871, 1883, and twice within a week in 1898. In the 1898 events, you had, again, two references to a cyclone and/or tornadoes, one of which took place here.
These rare photographs from the old Mechanicville Mercury newspaper show the aftermath of a devastating tornado that struck at 8:15 on the night of July 2nd, 1916.
Came through the cemetery and the Talmadge Park area where it upset and tore down lots of trees, did some house damage. And then when it got close to this area here, literally picked up a roof and threw it across a couple of buildings through the large window in the Methodist church. When it hit here, it kind of took a northerly route and went up along the river to Stillwater and hit Stillwater fairly severely.
In more recent times, Dr. Loatman notes damaging storms in 1969 and 1986 and shares his own experience with the devastating May 31st, 1998 tornado.
And I drove right into the head of the tornado. I had the worst experience with hail I ever had in my life. My wife begged me to stop. My wife said, "Don't turn around now, everything behind us is black." And I took a right-hand turn, the tornado took a left.
Local research implies that the unique terrain in this area could be a key reason why these hot zones exist. And much of that research has been done here at the Albany office of the National Weather Service. Ken LaPointe is a forecast and research meteorologist with the office and a local severe weather expert who knows that strong thunderstorms form when rising air, moisture, and instability in the atmosphere coexist with strong wind shear.
When we talk about shear, we mean the winds turning as you go up in the atmosphere. At the ground, they may be south at around 10 miles an hour. We get up to 5,000 feet, they may be southwest or west at 40 or 50 miles an hour. So that type of increased speed and turning of the winds can be favorable for severe storm organization.
Tens of thousands of thunderstorms each year evolve in this type of environment, but only a small percentage are severe, and an even smaller percentage produce tornadoes. It's only recently that research has shed some light on specific conditions that can nudge a thunderstorm into producing a tornado.
The shear through maybe the first about 4 miles of the atmosphere may be critical in developing rotation in a thunderstorm, but whether you get a tornado may be more dependent on the lowest half mile to a mile shear. And that's where the terrain is going to affect the winds the most.
The Mohawk, and especially the Hudson Valley, may be among the most influential pieces of terrain in this area.
We get a little extra instability or energy for the storms in this area as moisture from the Atlantic and the Gulf states comes up the Hudson Valley. And we also get a little more what we call shearing of the winds in the Hudson Valley. And under certain circumstances, the Hudson Valley helps increase the shear in the lower atmosphere, and that's an important factor in tornadoes.
It's an important factor because wind shear makes the air spin. And if a thunderstorm interacts with spinning air aloft, it can begin to rotate, becoming a supercell. And it's the supercells that sometimes go on to produce tornadoes. Here's meteorologist Tom Maley.
Supercell thunderstorms are an awesome force of nature, towering up to 65,000 feet and moving at speeds of up to 60 miles an hour. They can last for hours and produce damage over vast distances. This supercell thunderstorm hovering over Round Lake in Saratoga County on May 24, 2004 was part of an outbreak of supercells over the region. The low-hanging cloud under the storm's rain-free base is called a wall cloud. The wall cloud marks the lower portion of the storm's rotating updraft and often precedes a tornado. On radar, supercells often show a specific signature. This one tracked through the capital region during the evening of August 13, 1999.
And it's this notched region in here and this little pendant that's hanging down to the west. That's what we call a hook echo, and that indicates that there is a circulation within the storm.
And that circulation area can sometimes develop into a tornado. In this case, no tornado formed.
Now, exiting Waterford, exiting Lansingburg, exiting Tahoe.
Instead, this path of toppled trees and damaged homes in Colony was caused by 80 to 100 mile per hour straight line winds. Winds not uncommon with supercell thunderstorms.
It was as good as it gets, but it did not produce a tornado. Not every supercell spawns a tornado.
Meteorologist Hugh Johnson is a severe weather expert with the Albany office of the National Weather Service.
Anytime you have a supercell, the chances of getting severe weather are excellent. Even if it's not a tornado, I'd say you have at least a 3 in 4 chance of getting some kind of a severe weather report out of it.
Why some supercells produce tornadoes and others don't is still a mystery, but researchers do have some clues.
The interaction of the rotating updraft with downdraft air coming from the storm helps produce an increase in spinning near the ground, which will produce our tornado. Sometimes the weaker ones can form out of relatively weak thunderstorms. You have a thunderstorm updraft intersecting with a boundary, and you get a spinning action, a small spin up of a tornado.
That was the case here in Florida, New York on June 16, 2002, when this well-defined but weak tornado developed from a small thunderstorm. On July 21, 2003, however, many more factors, including a round of thunderstorms earlier in the day, contributed to creating the tornadoes and this aftermath, which stretched about 175 miles from Palinville, New York to Cavendish, Vermont.
Those first thunderstorms cooled the air over the Albany area quite a bit, so we had very cool air over our area, and then south of that line, very warm, muggy air, so nice contrast in air masses there and a boundary in between. It turns out when this line approached the Hudson Valley, it intersected this old boundary here, and that's where the thunderstorms really intensified.
The tornadoes on July 21, 2003 produced $1.5 million in damage. On Labor Day 1998, however, severe thunderstorms produced 10 times that amount in New York, illustrating the power of straight-line wind, hail, and lightning. We'll look at these other destructive forces when Storm Warning 2 returns.
The word derecho is of Spanish origin and means straight ahead. In meteorology, the word derecho is given to large and highly organized thunderstorm complexes that produce straight-line winds in excess of 60 to 100 miles per hour. Such thunderstorm systems can spread destruction over hundreds of miles.
Derechos are an extreme example of severe thunderstorms on a large and organized scale. Their destructive power, fortunately, is rare in the Northeast, occurring on average 2 or 3 times in a decade. The last derecho here occurred on September 7, 1998, producing extensive damage in the Mohawk Valley, especially here in Fulton County.
The trees went through our living room.
This severe thunderstorm was captured on our Augustyniak Skycam on July 21, 2003. It was a localized storm that produced 60-mile-per-hour winds and blinding rainfall. It's a more typical example of the smaller, quick-hitting type severe storms that occur here with some frequency in the spring and summer. Large hail is also a threat from severe thunderstorms, forming as the updrafts and downdrafts inside the storm toss ice up and down through the cloud. In each round trip, a new layer of water freezes on the surface of the ice, causing it to grow. When the hail gets too big and the updraft can't suspend it anymore, it falls to the ground. The stronger the updraft, the larger the hail. On Memorial Day, May 28, 2001, thunderstorms rained so much hail on Augustyniak Colony, Clifton Park, and Albany that the hail covered the ground up to a depth of 4 inches in some spots. And on June 20th, 2001, this gigantic hail fell on Coxsackie in Greene County. Measuring up to the size of baseballs, it damaged up to 80 cars and wiped out 99% of the apple and peach crop in the town of Climax. And hail shattered windows and homes, punctured vinyl siding and dented cars from Eagle Bridge to Buskirk, White Creek and Cambridge in southern Washington and northern Rensselaer counties on May 24, 2004. In some places, the hail fell for an unbelievable 20 minutes.
This is the first in my lifetime. I'm 59. I have never witnessed or been involved in a hailstorm to this extent. It was incredible.
It was so incredible that even 18 hours after the storm, piles of golf ball-sized hail remained on the sides of many roads after having been plowed the night before. All thunderstorms, whether severe or not, produce lightning, an awesome but sometimes deadly force of nature, but not one yet fully understood.
Since Benjamin Franklin's fabled key kite experiment, lightning's been a source of fascination and study. In the early 20th century, primitive studies at GE's High Voltage Lab in Pittsfield were aimed at understanding lightning's effects in an effort to protect property. Today, at the University at Albany, lightning studies are a little more sophisticated, but even with today's technology, there are still more questions than answers.
That's lightning coming down the channel and then going back up the channel.
Dr. Vincent Idoni is one of the nation's leading lightning researchers.
Here's something really basic. Nobody still really understands why a lightning has to have multiple strokes. Why isn't it one big electric discharge? And we're still at the stage where we really have a pretty poor understanding of all the physics involved, because the lightning channel is a pretty complicated thing.
It's clear, though, that lightning channels a dangerous amount of electricity and is responsible for an average of 500 injuries and 100 deaths a year in this country. And New York State ranks in the top 5 for both lightning-related injuries and fatalities. To put the amount of electricity flowing in a lightning strike into perspective, think about this.
Let's say you were working on your automobile engine and you accidentally dropped, say, a long screwdriver across the terminals of your battery and you short-circuited that 12-volt battery. You might get something on the order of an ampere or so of current flowing that way.
And we all know you can get a pretty good zap from your car's battery.
With the lightning, in general, you're getting on the order of 10,000 times that amount of current.
If struck directly, that amount of current can be fatal. Most lightning strike victims, however, are struck indirectly. To stay safe from lightning inside the home, stay off corded telephones and away from electrical appliances and the plumbing. If lightning strikes your house, the current will flow through the wires and pipes on its way to the ground.
Outside, stay off and away from metal objects like bikes and golf clubs and this fence. If you can't get inside, then make yourself the shortest object around without lying flat. Lightning looks for the easiest path to the ground, making tall objects more likely targets than short ones.
On a boat, keep a portable NOAA weather radio handy.
The continued threat of afternoon and evening thunderstorms.
The first sign of a thunderstorm, head for shore. And keep in mind this rule of thumb: if you hear thunder, there's a threat of being struck by lightning. We traveled to Boston to take a close look at lightning and take part in a special demonstration using a machine at the Museum of Science. That machine is the world's largest air-insulated Van de Graaff generator. It's a device that makes lightning. 3 massive rubber belts transport negative charge to the top of the generator spheres. When the charge differential between the spheres and surrounding bodies becomes large enough, lightning results, much as it does in nature. Here, 1,000,000 volts of force will push lightning through 20 feet of air. In the real world, 100 million volts of force can push lightning through up to 10 miles of air, allowing it to strike far from a thunderstorm. This metal cage simulates what happens when a car or an airplane is struck by lightning. It's loud and it's kind of scary, but the charge travels harmlessly along the outer shell, leaving me safe inside.
What's happening is when the lightning bolt hits the cage, it's hitting that metal and causing that metal basically to become a magnet for a split second.
Okay.
And that's setting up magnetic fields which repel the charge to the outermost surface.
Lightning created by the Van de Graaff generator displays the same properties as natural lightning. Notice the forking of some of the bolts. That effect in nature begins as invisible charge moves in a tiny channel from the cloud to the ground.
It makes the channel in steps, and it makes them in steps that are about 150 feet long every 50 millionths of a second. And that process will actually split and form branches, and those will split again, and that's how you get that branching tree trunk shape.
Coming up when Storm Warning 2 continues, we'll have a historical look at past major severe weather outbreaks and tell you how to stay informed and safe when the next one hits.
Thunder results when lightning superheats a narrow channel of air to a temperature 3 to 5 times hotter than the sun. The resulting explosion of hot gases out from the lightning channel and inward rush of the surrounding air creates a shock wave. That becomes the sound wave we hear as thunder.
Our severe weather season typically runs from mid-April through September, with a peak towards the end of May and again in late August. Here's a historical perspective on just a few of the big severe weather outbreaks that have hit our area in that time frame. June 24th, 1960, Rotterdam and Schenectady are both hit by a vicious tornado at 5:30 in the afternoon. The storm left buildings and parts of both towns in total ruin. August 28, 1973, West Stockbridge, Massachusetts is hit by the second deadliest tornado in state history. The storm killed 4 at this truck stop off the Berkshire spur of the Thruway in a matter of minutes. June 16, 1974, a tornado with winds estimated up to 200 miles an hour left the Terry Morris car dealership on Route 50 in Burnt Hills obliterated. This is where the storm ended its 29-mile rampage through parts of Greene, Albany, and southern Saratoga counties. July 10, 1989, the most powerful tornado on record in New York tracked through parts of Montgomery, Schoharie, Albany, and Greene counties, damaging or destroying buildings and toppling trees in the especially hard-hit towns of Schoharie, Carlisle, and Central Bridge. May 29, 1995, Hillsdale, New York, and Great Barrington, Massachusetts are hit by disastrous early evening tornadoes. The storms killed 3 and damaged or destroyed 100 homes and demolished the Great Barrington Fairgrounds. July 15, 1995, a super derecho left this path of destruction after producing wind gusts of 65 to 100 miles an hour throughout upstate New York and western New England. A half a dozen people camping in the Adirondacks were killed and millions of trees felled. May 31, 1998, a devastating mid-afternoon tornado tracked through Mechanicville, Stillwater, and Schaghticoke, leveling structures in heavily populated areas like the Vial Hill neighborhood in Stillwater. Property losses exceeded $65 million. And our most recent event to date, July 21, 2003. 14 recorded tornado events occurred in just over 2 hours in the Hudson Valley and in Vermont, leaving a half a dozen injured and millions in damage.
To stay safe in tornadoes and severe thunderstorms, seek sturdy shelter away from windows. The basement's the best place to be, but if you don't have one, choose an interior closet or bathroom on the lowest floor. Those rooms will hold up the best to powerful winds. To stay informed, stay tuned to Channel 6. With the proven technology of live instant Doppler 6, we'll show you where the severe weather is now and which towns it will hit next.
County and up into the western Adirondacks now.
And between live updates, our programming will look like this, giving you a continuous live picture of instant Doppler 6. In the event of a tornado, we're on the air continuously until the danger has passed.
Severe thunderstorms and tornadoes produce more injuries and deaths east of the Mississippi River than they do in Tornado Alley, where they happen much more frequently.
And the perception in this part of the country remains that that kind of weather can't happen here.
It's because of that perception, people are often caught off guard, not knowing what to do when severe weather strikes.
Don't be caught off guard. The best defense is to have a safety plan in place and to stay informed before and during severe weather.